So we have to find the smallest positive integer n such that this inequality is satisfied. So let's look at the inequality. That is, we have this just to show that the sequence given by, the infinite series made up by this converges to what? 5 over 2. So what we can do is 5 here can be factored out as a common factor. So we got 5 over here, and then the inequality may be treated equivalent to this inequality here. We can divide by 5. Okay, so we got 0.00001 divided by 5, and after that, so I can put an equivalent sign here, and yes, we divided by 5. So if we look at this inequality here, let's recall that this sum may be evaluated by the rule that, this is how we got the convergence of our geometric series. So in here, if we look at n equals 1 to capital N, 1 over 3 to the power n, then what we notice is this, that this will be by that, by using this equation, we will have r is 1 over 3. So what we have here is 1 over 3, and then minus 1 over 3 to the power capital N plus 1, and I'm just going to write 1 over 3 to the power, because 1 to the power n plus 1 will be simply 1, and in the denominator what we have, 1 minus 1/3, and we will go ahead and quickly simplify it. So what do we have here is that if we look at the numerator, we can factor a 1/3 out, and if we factor a 1/3 out, then what will stay in the numerator? Simply 1 minus 3 to the power capital N, and then let's just write what we factored out. We got this here, and then we have 1/3 that we pulled out as a common factor. Okay, and then in the denominator, 1 minus 1/3 becomes how much? 2/3. Okay, so this is 2/3. So what we get here simply is this 1 over 3, 1 over 3 will cancel, and we get 1 over 2 times this quantity, right? So let's just go ahead and simplify our inequality. That is the inequality that we are trying to work on. So we have this here, and this is now replaced by this value, and this would tell us, okay, that we can factor 1/2 out as well. Okay, so let's just factor this 1/2 out. So what will happen then is, we got this out. So, okay, so inside we have 1 minus 3 to the capital N minus 1 equals, has to be less than the quantity on the right. I didn't simplify it yet. So anyways, let's just go ahead and look at this here, that this one and this one will cancel inside. Okay, and then you have multiplication by 2, and I'm not putting any connective there, so just you to put it on, and then this will be the same as if we remove the absolute value signs. We just got 1 over 3 to the power capital N equals 0.0002 over 5, or here, let me just at least write this here. That is, it looks awkward without having anything in between. Okay, and then I'll just copy and paste it here. Okay, good. So what we have is that so now from here we have this, that we got 1 over 3 to the n, which will become 3 to the power negative n, and that has to be less than how much? This quantity. That's what we want. And now to get n down, we may just make use of logarithm. So what that will tell us, if we take logs of both the sides, so let's do that. And here we got, let's take natural log for instance, and natural log here as well of this quantity here. Okay, so we got this right here. So what that gives us is that negative n ln of 3 is less than this quantity right here. Okay, we can simplify, we can do the arithmetic in here if we want to, but I'm just being kind of lazy here. And now if we divide by negative ln of 3, okay, then what will happen? Ln of 3 is a positive number, so negative ln of 3 will be negative, so this quantity will change to, sorry, the inequality will change to greater than, it will reverse. So we have this here and divided by negative ln 3. Now you may use your calculator to obtain this value right here. So n has to be greater than how much? 11.3135, etc., etc. So the lowest value that we will get for capital N is, to satisfy this criteria, is that n has to be greater than or equal to how much? 12 for this inequality to be true. And then you can use your calculator just to see that that we have this here. Say we put 11 over here, then what you notice is that you can see it's slightly more than 0.00001 because we have a 4 here, and sorry, and if you put a 12 here, that's our minimum requirement, and after that this will be increasing. Like as we increase this value, this quantity increases, so the difference will decrease. Okay, so if we do that, then you can see we hit that mark, right? Okay,